Good afternoon, everyone. My name is Katie Boone, and I'm the Marketing Manager for the NSF ISR division here at NSF International. I want to thank you for joining us for today's webinar, where our speakers will discuss the topic of preservation. I'd like to introduce you to today's speakers. First, we have Don McFarland. He is our Aerospace Technical Scheme Manager here at NSF ISR. Don was born into aerospace at the U.S. Air Force Academy Hospital and has been around it ever since. He's been involved in third-party auditing for 10 plus years and with NSF for the past 3, currently serving as the Technical Scheme Manager. Mike McRandall is the Business Unit Manager here for the NSF ISR Aerospace Division. Mike grew up in the aerospace and defense sector, working with fixed wing and rotator aircraft before moving into the missile defense and sensor systems. He transitioned to the certification body side around 6 years ago and has been the business unit manager for our aerospace for 4 years now. Just to give a little detailed information about today's webinar, we'll be putting everybody on mute during the session, and then that's to prevent with any distractions. Please use the chat function for any questions you might have during the webinar. We'll be able to do a question and answer session at the end with the time slot we have left. After the webinar, I'll be sending out an email that has a PDF of all the slides as well as a recording of the event. So don't worry if you don't hear anything or you miss anything, you guys will receive all of the information after the event. I'm going to go ahead and pass it over to Don, let him get started.
Thanks, Katie, and thanks everybody for joining us on this next installment of our webinar series. As before, we're going to follow a similar agenda to what we've done in the past, and I'll show you that in just a moment. Before we start with that, though, I want to start with a poll question. So this is more of an introductory poll associated with the topic we're going to go through today. We've discussed product safety in the past, but I wanted to poll the group and determine from your perspective if there is a tie between product safety as defined in the standard and the preservation of the product or the preservation of the service. So give everybody just a couple minutes here a couple seconds to go through and complete that. The preliminary results are warming my heart. Give everybody 5 more seconds. 4, 3, 2, and 1. Very good. I certainly appreciate it. This, like I said, warms my heart to see overwhelming majority say for sure there is a connection between the standards definition of product safety and preservation. We'll go through that in some detail through this presentation to make sure we understand what that connection is and how it all ties together. But I want to start with this quote from one of the godfathers of quality, if you will, W. Edwards Deming. And it says you cannot inspect quality into the product that's already there. And the reason that that was tied into the teaser for this session, as well as the introductory slide, is we know what the product has to do. We create an infrastructure, we create an engineering plan, we create an environment where we're going to build that product, and we're going to either build it correctly or not build it correctly. Quality can be good, quality can be bad, and what he's saying is we're not going to inspect good quality into the product, we're not going to inspect bad quality, we're going to build it into the product from the get-go. So it's important to understand what the customer needs are, build our system surrounding those needs, and when I say customer, it's both internal and external. Using the standards vernacular, it's really that context of the organization piece. Okay, so with that teaser, we'll get started. The agenda, as we know, transition plan benchmarks, preservation definitions, the implementation thoughts, some commentary from Mike McRandall, who's on the call with us as well, and then we'll get into the questions. Our first slide is associated with those transition plan benchmarks. We know that September 15th date is looming. The recent change or recent clarification that came from the SR 003 allowed for a little bit of leeway associated with the cert decision piece, but the audit still has to be done prior to that September deadline. So we want to encourage everybody, if you have not scheduled that, make sure you've got it in contact with your account managers. If you're not an NSF client, make sure you're contacting your account manager at your respective CB, or give us a call and we'd be happy to help you. So with that said, we'll move into the preservation definitions. This comes directly from the ISO and AS standard, and as we know, the difference here is in the bold and italic text. So anything that's bold italics like this is going to be the AS edition, and anything that's standard text is going to be the ISO verbiage. So if we're looking here, the preservation section 854 says the organization shall preserve the outputs during production and service provision to the extent necessary to ensure conformity to requirements. Preservation can include identification, handling, contamination control, packaging, storage, transmission, or transportation and protection. So it's pretty encompassing. The aerospace standard goes on to clarify or add, if you will, that the preservation of outputs shall also include, when applicable in accordance with specifications and applicable statutory and regulatory requirements, provisions for cleaning, prevention, detection, and removal of foreign objects, special handling and storage for sensitive products, marking and labeling, including safety warnings and cautions, shelf life control and stock rotation, and special handling for storage for hazardous materials. Wanted to highlight a couple notes on this before I go further, and they are going to be tied to the source for these requirements. In both the ISO verbiage and the AS verbiage, it really points to conformity to requirements. On the AS side, it more specifically says, in accordance with the specifications. It doesn't say customer specifications. It doesn't say external specifications. It just says specifications. But it also includes any applicable statutory and regulatory requirements. And we know that statutory and regulatory supersedes anything within the standard based on early verbiage within the document. So it's going to require compliance with statutory and regulatory requirements and any applicable specifications from ourselves, our customers, industry, the stakeholders, interested parties, whomever they might be. Okay? And I believe I just stole my thunder for the next slide in the implementation thoughts. And that is that really a lot of this is contract driven. There's not much in the standard that talks to, as we've seen, there's not much within that standard that talks to the preservation requirements. It's really that one paragraph, that one section here. That's it. That's all there is. But as we're going to see, there's a huge tie, a huge connection between this section and a number of other sections within the document. So we need to understand our customers' requirements, our contract requirements, and our internal requirements, because as it says, the verbiage is to preserve the outputs to ensure conformity to requirements and preserve the outputs in accordance with specification and applicable statutory and regulatory requirements. So it's really the same intent between both the ISO and the AS standard. The AS just has added some more specific wording. So what does that mean? As we look at the examples here of cleaning, cleaning can be a number of different things. If I'm a machine shop, it can be removing cutting oils, removing chips, removing contamination. It could also mean that I'm removing any contaminants from my scrap, particularly in a company that has a customer-supplied material. I did one of these audits last week in Japan. The customer is providing them the blank, the alloy, and they are doing some machining on it, but they have to account for the chips. Well, the customer is very particular about having alloys of chips segregated, and not only do they have to preserve the material itself, but they have to preserve the scrap now, the chips, the waste products. So they have to ensure that those are clean and free of additional debris, clean from contaminants, and free of FOD, free of foreign object debris, associated with dissimilar materials. It's all metal, but they want their materials to be segregated. Another example here could be some of the contaminants that we put on there unknowingly, like silicone. We've heard a lot of problems that have arisen from silicon and silicon on our persons, on our gloves, on our handling tools that have caused issues with adherence of the chemistries used in surface finish. And if I have a requirement contractually to have silicon-free tools or silicon-free workstation, I need to make sure that I'm adhering to that. I know at least a couple of the primes have banned those silicon-based name bands, like the yellow band that Lance Armstrong had. Those were banned in a number of facilities and throughout the supply chain based on contract requirement because of the silicon contamination potentials. And really that caused issues in the surface finish adherence at later stages in the product realization activity. Some other issues that might arise from this would include the application of, say, a conformal coat or some surface finish coating or some protectant coating on the electronic side. The J-Standard document, J-Standard 001, the IPC Cleaning Handbook are very particular about what a clean surface is, both from an ionic standpoint, from a visual standpoint, from a foreign object standpoint, because in that space, the electronic space, those ionics can cause functional failures. They can end up causing dendrite growth. They can cause chloride growth or ion growth. They can end up causing the product to short. So it becomes more of a functional thing than a visual thing. In addition, we have some requirements for clean rooms where that invisible particulate could cause some issues based on either a functional failure from an electrical standpoint, or perhaps it could be a mechanical standpoint. One of my products in the past was a tiny brushless motor, and we were talking about some solder balls that were perfectly allowed based on the IPC suite of standards, but in its in-use environment, those solder balls could become problematic because they would cause this brushless motor to seize, and it would cause the device that we were building to not function as intended. And in this particular case, that device was a actuation system for a guided projectile, and of course, nobody wants the steering mechanism of a guided projectile to seize, because then it doesn't steer on the target like it should. So it's pretty important that we understand the facility cleanliness, the product cleanliness, etc. One other aspect of this that we may not think about is the end-use environment associated with that product and the chemistry that we're allowed to use for cleaning it as it's being manufactured, or the surface that we're putting on it so that it can be utilized in its end use. What I mean by that is the World Health Organization has dictated the types of cleaning materials that can be used on commercial aircraft to ensure that the germ growth doesn't occur when the product is being used in final configuration, right? As it's flying around the world with millions of people in it, there's a certain standard associated with how clean is clean and what chemistry needs to be used to ensure cleanliness. And the surfaces of the cabin have to meet a certain criteria in order to ensure that they can have those germicides used on them without causing deterioration. So obviously you'd have to know the end use of the product or the product safety aspects, and we'd have to ensure that we understand the contract requirements that says make sure you're using this chem film instead of this chem film, right? Seems pretty simplistic, but all of those are going to apply as we preserve the conformity of the product. Now, how am I supposed to understand this, or how am I supposed to know these types of things or the cleanliness requirements associated with it? Again, you have to really understand what the product is. The contract requirements should dictate some of this, But if you don't know your product, it's going to be tough for you to sort out what clean is or what the definition of clean is. Along with that, we may need to validate what clean means. As an example, within the electronic space, there is a method for validation, quantitative validation associated with clean through maybe an ionograph, looking for ionic signatures or ionic contaminant residues, or perhaps it's more of a qualitative test in a water break-free. Depending on the contract requirements, you may have to do one or both associated with demonstrating clean associated with your product. So that's clean. Let's talk about foreign objects. Again, foreign objects can have detrimental impact on the surface finish adherence, and I'm talking about maybe our chemical platings or our chemical converted coatings or films, epoxies or sealants or any of those types of materials. It can have some impacts on the ability to adhere to the surface. In addition, it can have some, an example of a foreign object could be an oxide, say a rust or a cupric oxide that may have some functional failures, or a corrosive material that gets in there and causes some issues associated with roughing the surface up. The functional failure associated with that could be electrical, could be mechanical, could be a lot of things. But we need to understand what the product does and what sort of things can cause issues for it. Again, some of the functional issues, we've talked about this a little bit, could be the electrical, the mechanical. That example, the brushless motor that I gave you, was the mechanical side. As far as an electrical failure, we had an issue with a gold finger that had some solder balls depositing on top of it, and it was causing a bump on the gold finger. And if you don't know what a gold fingers are, these are very, very thin layers of gold that are used to create the surface that controls the LCD or the displays on a board or on a unit. And there's a zebra stripe connector, it's called. It's a conductive connector that is made of like a rubber material with a conductive intermediate layer, and it can have it can be fairly finicky. In the particular instance we ran into had some solder balls that were deposited, causing like a 2 or 3 micron increase in the surface, and that was enough to cause an intermittent connection between the gold and the LCD because it wasn't at a flat enough surface. I was blown away by that, but it definitely caused an electrical failure, which then caused a functional issue for the end use environment. Some examples, foreign object standards here. Electronics, again, the J standard series, the IPC standards from the 600, 610, 620 documents, very, very commonly invoked in the electronics. They're going to refer to particulate matter, which would include, something as simple as a human hair. A foreign object could also be an air bubble that's embedded in some conformal coating, because really you don't know what's inside of that air bubble. You don't know what sort of contaminant has caused it. Flux inside of a solder joint that's created a void can definitely be an example of a foreign object as well, because that flux is still ionic in nature if it hasn't been cleaned, hasn't been activated properly, and can cause some issues for reliability. Some commonly invoked standards associated with the contracts that I've seen have been this newly created, newly released AS9146 document. It's a great standard associated with FOD. One of the more legacy type standards is NAS 412. It's a good document, but it really is focused more on ramps and tarmacs, but it was the gold standard associated with FOD control for a long time. Regardless of what document is invoked in the contract, you need to adhere to that document. Even if it's NAS 412 that really isn't applicable to a manufacturing facility, if your contract says thou shalt, you need to. And take it for the value that it offers, and ensure that you have a program that's designed around what you do and why you do it, and really the product that you're building. Because you can tailor both of these programs associated with the nature of the work you're performing. But they include a documented program, they include training, they include awareness. All of those same things that are required by the AS standard are really supported by these two different FOD standards. There may be some other customer-specific standards that are invoked that you may see referenced, but those really are the commonly invoked industry standards that I've seen. The next one is associated with sensitive product, and this is a really broad criteria, a really broad category, and oftentimes we think about ESD and moisture sensitivity here, but remember, our product can be intellectual property, it can be a physical widget, it can be a service. So some other considerations here might be the temperature and humidity, back to that work environment piece, right? It could also be the ESD and the moisture-sensitive components that we've already talked about. That's silicon-free. We can't have silicone. It could also include something like noise, because some parts do break down, or some products do break down at certain frequencies of noise. Likewise, there are light-sensitive components that may have a sensitivity to a particular heat or intensity of light, or they may not cure if they're not seeing a certain intensity of light or temperature of light even. So we need to make sure we understand that. Biological, meaning if I'm building something that has a detection capability for biological agents, I probably need to make sure that I'm storing it such that it's not going to have harmful effects associated with the maybe detection agents that are inside of it. Or if I'm using some live agents as a part of my testing process, I need to ensure the integrity of those biological agents, or radiological for that matter. For corrosion, and that's another one that probably a lot of the companies that we deal with on a daily basis face, products may be sensitive to air and moisture and may cause corrosion. We need to make sure that we're protecting that, maybe with a rust inhibitor or some other product that's going to prevent the corrosion from developing. All of these things seem pretty easy, pretty simple, but it's amazing to see how often this sort of stuff gets missed. The last one on here is kind of an abnormal one, something that you wouldn't necessarily think about as far as the preservation of product, but I'll challenge you to question, or challenge you rather, to consider special handling for storage and storage for sensitive products in terms of the intellectual property aspect. If products can be sensitive in terms of the intellectual property or the regulatory aspect, and we know that regulatory and statutory rules are invoked here, would ITAR, EAR, Canadian Controlled Goods, or any national equivalent, would that not be something we need to consider here? Because these are sensitive products for defense applications or for proprietary reasons. So we would want to have some handling and storage protection associated with ensuring that that information isn't being accessed inappropriately. Some example standards you can see listed here. A very common one for the ESD program is S2020, which does require a documented program. So if you've got that invoked on a contract, you'll need to have some semblance of an ESD program. If you have questions on that, the ESD Association would be happy to answer them, or shoot me an email. I've got some background here as well. One that I find not necessarily as addressed as well as it should be is the moisture sensitivity, and I'm going to point to J Standard 33 associated with that. So this moisture sensitivity portion is where components, because they are hygroscopic, they can adsorb moisture into them. As they go through a thermal cycling process associated with soldering, that moisture tends to egress. Unfortunately, it does it through vaporization, and vapor expands 1,700 times volume. So it's got to get at one droplet turns into 1,700 droplets of steam, and it has to get out of a very, very small chimney, if you will, inside of that product. And what happens then is that product tends to pop or create a phenomenon known as popcorning, and it can have some mechanical property damage associated with it as well. So they've determined electronic components have a moisture-sensitive classification associated with them, and every component will have it. It'll be on a numeric scale from 1 to 6, and the storage conditions are determined by J Standard 33 based on that numerical classification, which will include the time it's allowed to stay in ambient environment, the temperature and humidity requirements associated with that environment, and how we track hours to decrement time exposed. All of that's going to be found inside of that J Standard 33 document. There are a few others that will be invoked and referenced within that, but that's certainly a good one to pick up. Some other documents here could be associated with the ITAR, EAR, Code of Federal Regulations. We've talked a little bit about those. I'd also point you to some of the packaging specs here. So these are associated with crates. These are associated with gaskets, because those rubber or curable materials will have a requirement that they have to sit in a certain level of protection. There's a similar standard that exists for packaged metal products to ensure that they've got a lube on top of them so that they don't become damaged in storage, and that the packaging can ensure the corrosion prevention as it's sitting in storage as well. Really, again, it's all about understanding what your customer requirements are, whether they're customer-specific specs or it points back to a MIL-PERF document or even an ASTM type spec for the crates. And this could be something as simple as it must be pressure-treated lumber to it must be divided and using 10 penny nails on 10-inch increments, depending on the packaging configuration that's been determined. So just different things to consider here. The next slide talks about marking and labeling, including safety warnings. And as we know, that marking and labeling is going to provide some pretty integral information to both the packaging and to the product in terms of the identification, maybe the accuracy for the traceability and the configuration of that. How about from a legibility standpoint, making sure that marking is readable, whether it's a human character or it's legible from a barcode or a 2D matrix type standpoint. If the barcode can't be read, do we now have a marking and labeling concern that would fit into this preservation component? How about RFID, and how does that fit into here? Obviously, that RFID is contractually invoked from a lot of the government, the military contracts, so we'd want to ensure that the RFID can read, otherwise you won't get paid, and you'll get a non-conformance issued against you. Now that we've got a legible mark on there, we want to ensure it's permanent. We want to ensure it's compatible with the material so that it's not causing either deterioration of the product, meaning I've put something that's non-compatible and corrosive and will eventually eat the material away, or perhaps something that's not adhering to the surface because I've improperly cured it, or I've put it over a silicon surface or a silicon contaminated surface or an oil contaminated surface, and it's not going to stay attached. There's a lot of things to consider there. The light, temperature, corrosives, radiological, biological. I mean, all of these could be part of that safety warnings as well, and ensuring the permanence of the safety warnings, because nobody wants to open a box that contains a radiological specimen and not see a sticker or not understand what they're getting before they started playing with it. The reason this becomes so important, if we look at these gaskets here on the right, I mean, there's a number of different sizes and a number of different diameters there. It's really tough for you to understand what the compatibility is associated with those materials just by looking at it, right? If you've ever played with fuel line is very different than standard hose. If you put just a standard rubber hose on there, there's a good chance that the fuel is going to corrode it and it's going to wear out. You're going to have a leak. So we need to make sure that the material we've selected is compatible, There's compatibility charts associated with that. But as we receive the product, we need to have the identification so we can confirm that it is the correct material and it is the correct configuration for the end use application. And as it says down here, awareness of the contents and the applicable handling. We talked in the last slide about the importance of ESD and moisture sensitivity and things like that. If it's not labeled as being ESD sensitive or moisture sensitive, there's a good chance that it's not going to be handled properly. I've been in a number of facilities where they don't handle it as ESD unless it comes to them in a silver Mylar bag, a shielding bag. And I'll tell you that's not a good practice. If it's got electronics, it's probably worthy of handling as ESD, even if the predecessor, the supplier before you did not. And if they didn't, frankly, we should be questioning the conformance of the product or the integrity of the product, because there's a good chance they may have caused an ESD event. So we need to be careful about that. And there may be some design implementation or some design issues that predicate or don't necessitate the need for ESD packaging because they've got it built into the configuration. But if you've got bare circuit cards, bare components, it's certainly something that we should be considering. And we should be including those safety warnings so that when we ship it to our customers, they understand the importance of handling it properly as well. Next one is shelf life control, stock rotation. Considerations here can be for chemicals or curable materials, so the raw chemical itself, a curable material like a gasket or an O-ring or something to that effect, anything that's been made out of that two-part material, because those do dry out. In addition, some greased parts like bearings, anything that's got a grease embedded into it, probably needs to be considered as a shelf life material, because that is considered a shelf life material in the final configuration. There is, on the right-hand side here, you'll see some common definitions that are used associated with the working properties for those chemicals, those adhesives. So we have shelf life, pot life, how long before it goes bad. Sometimes pot life refers to once it's mixed, how long you have to work with it, versus shelf life is the prior to mix, it's in the OEM packaging, how long until it expires. The assembly open time is the amount of time you have to apply the adhesive. Again, sometimes that's commingled with the definition of pot life there. It really depends on your contract and what the OEM is going to say. Closed assembly time, this is the amount of time that it needs to dry and clamp so that we ensure that the surfaces have been held together at the level they need to ensure that permanent attachment. Cure time, time until the glue reaches its full cure or full strength. And then there may also be a sandability time or, frankly, a handling time, because we may not need full cure for it to move on to the next stage. So there's going to be progressive times associated with when it's okay to handle, depending on the level of handling that's been done. We may have a working temperature range, meaning once I've mixed it up, I can handle it within a certain temperature or humidity range, because that glue is going to be hygroscopic. It's going to absorb the moisture into it, and it's going to cause some consistency issues, or it may start to cure and cause some working issues where it's not going to flow properly. As it says here in my second bullet, there is going to be some dependence upon how it's handled in terms of the temperature, the humidity, the lighting maybe. The temperature of lighting or the intensity of that lighting is going to have an impact. If you played with a UV curable material, you'll know that leaving it in a fluorescent environment is going to have some detrimental impacts to it. So you may need to consider that as you're looking at how you're handling it. It's not just an expiration date, although that's probably the biggest piece of low-hanging fruit here. There may be some issues outside of just the expiration date or pot life or open time that need to be considered associated with the consumables. Best source of information associated with all of this would be the OEM or the industry spec associated. May not, as we know, the product may not go instantly bad on the date, but as a company, we cannot arbitrarily deviate from that date. If we say that we're going to use it past that shelf life date and we have some engineering that substantiates it, and we have the ability to disposition material as used as is, because we have design authority, then we may be able to deviate. Otherwise, we're going to have to adhere to those OEM specs or the industry specs or the date that's been put on the container or contained within a spec sheet. Now, one of the items I wanted to mention specifically is the thread locker type materials, and I won't name any particular brands, but those generally don't have dates clearly identified on them. They'll have a lot code number. Some of them will have a date, but even those that have a lot code number, they will have an expiration date, and it's embedded into that lot code. So it's up to you to go determine when the batch was made, or in some cases it's based on when it was shipped from the manufacturer, not the distributor, but the manufacturer. It's 18 months as an example from that date. So it's going to be up to you to ensure that you clearly understand how long you have to work with it. The thing that's worth mentioning here or correlating this to is the shelf life of milk. Milk doesn't necessarily go bad on the day that it's stamped on the carton, but I'm the kind of guy that's going to dump it down the drain the day of or the day before because I don't want to take the chance. I don't want to take the risk. There are plenty of people out there that are willing to sniff test the milk. I'm not that guy. When we're dealing with airplane parts, it's not worthy of sniff testing. If we're dealing with parts that are having an impact on lives or potential impact on lives, it's not worth doing a sniff test. So we want to make sure we truly understand the product safety aspects, and then control it so that we're not having or putting risk where it's not due. The last section here from the standard was associated with storage of hazardous materials. Again, considerations: strength, deterioration, personal protection, compatibility from the product and the environment. And these could be, again, our biological specimens or radiological pieces. They could be the chemistries or the corrosives that we're going to use through our processes, or even the paints, the chemical platings that we're going to use, or the acid etch that we're going to use. All of these may have a sensitive, a requirement for some specific handling. It's not just about protecting our people, although in my mind that's pretty high on the list. We got to make sure we're protecting the people. We also can't commingle chemicals that aren't capable of being commingled. And one that should come to mind here is bleach and ammonia. If you mix those two, it creates some pretty bad things. So we need to make sure that we're storing hazardous materials in such a way that it's not going to hurt our people and it's not going to harm the product. It's not going to create any noxious chemicals that could have a detrimental impact to the product or to the people working on it, to that work environment. The other consideration, again, dependence upon handling, because the temperature may cause a difference in how it's being, how it's going to react. Certain chemicals have to be stored in a certain temperature range in order for them to not be volatile. Again, the humidity may cause some other impacts, just things to consider without getting too far into the weeds here. This slide really talks to the importance of the interrelation between the clauses. As we've talked through all of these, we've really touched on the importance of infrastructure. And what I mean by infrastructure is the equipment, the hardware, the product, workflow, the space that workflow is being done in, ensuring that we have appropriate equipment, ensuring that we have good containers, good vessels for all of these products, ensuring that we have the proper racking that's not going to cause rust lines to develop on the material, or we've got pallets that are pressure treated so that we're not introducing contaminants into the material. From a work environment standpoint, ESD and the temperature and humidity, lighting, all of that fit into there as well. We know the preservation clauses have, we've just talked through those, and there's definitely a tie, obviously. Product safety, we've got to understand what it does in order for us to understand how we can help to preserve the conformity of it. One of the fun stories that I've heard through auditing was associated with a chemical, a two-part chemical that was used for sealing some stealth skins on a military weapon system, a military airframe. And that particular chemical was being mixed, and the operator that was mixing it was using a wooden spatula. Now, we wouldn't think too much of using a wooden spatula to mix chemicals ordinarily, but this particular chemistry was very sensitive to moisture. So as moisture was being embedded, the stealth properties of it were being broken down such that it no longer served its purpose. And now we're having some detrimental impacts to the final configuration of the product. Now, from an infrastructure standpoint, if I'm supplying the correct tools to the employee, from a work environment standpoint, if I'm minimizing the moisture that's in the air, the temperature associated with that so that it's not able to adsorb the moisture as much, I'm definitely increasing the product safety aspects as defined by the standard, right? I'm ensuring that that product is usable and it's in configuration. Operational risks have a direct tie here because this is where we're going to identify who can help, what the risks are associated with these individual processes and who can help to mitigate those risks and how we potentially mitigate those risks before they become reality. Again, as we've talked before, we're not going to fix everything, but this gives us an opportunity to identify what could go wrong and address it before it does. And really the last one here is the definition of requirements, and this is meant to be more of that context piece and the contract review piece. So not only are we defining who we are as a company and who our stakeholders are, but also the individual product requirements that are defined in maybe Section 8.2, so we understand what we're going to build and what requirements we have to adhere to associated with delivering the service or contract or product that we're going to, that we're contractually obligated to provide. So there's definitely a tie between all of these clauses. This is just a more in-depth view of those particular, or some of these particular requirements. So this is the point where you're going to hear my soliloquy associated with some of these beyond what I've already mentioned, and I'm going to reinforce some of the statements I've already made. Katie, I think Mike got kicked off for a second, but if you wouldn't mind, get him back into presenter mode, and I'll continue down here, and that'll allow Mike some time to chat here. Overall thoughts, we're entrusted with working on behalf of our customers and their customers, and frankly, their customers' customers. We need to ensure that we're doing good product. We need to assure that we are ensuring good product. We need to make sure that we're providing them with good stuff all the way down the supply chain, all the way up the supply chain. In order for us to do that, really that Hippocratic Oath applies here. First, do no harm. We need to make sure that we understand what we're doing, why we're doing it, and really build our system, build our company around fulfilling those contract requirements. And of course, in order for us to do that, we need to understand what those requirements are. Often the conditions created by non-compliance to these clauses, frankly, they can't be detected through the inspection aspect. It's stuff that cannot be visually seen. It's tough for, using ESD as an example, it's tough to see ESD failures manifest into a product failure initially at test. You hope that's where it's manifesting, but oftentimes it's not going to come up until it's exercised through, a field iteration or some work out in the field, and then it fails. Moisture sensitivity may manifest in a similar manner. but we want to make sure that we're creating an environment where the product isn't being detrimentally impacted. Back to that quote from our friend W. Edwards Deming, we need to make sure that we're building the system such that it's building quality into the product. Therefore, we don't have to inspect it into the product, because that's just not going to work. This slide, frankly, was an excuse for me to put a plug in for my Golden Knights, because they're doing great. But I wanted to tie it to the second bullet here, and that is that we need to assure that the product is cared for during all stages of realization, creating an environment where conformance is achieved. Every single person plays a role in winning. And that's the tie back to the Knights, is they're a team of misfits. They're a team of people that shouldn't win. There's no reason they should win, but they are. And every single person is contributing. Within your company, I'm not saying you're a team of misfits. You probably have a couple, just like every company, but everybody in the system, everybody on the team is important in assuring that the product is good. Because all it takes is one person not wearing the proper PPE, and the product could be impacted, or they could be personally impacted, or they handle it improperly and now it has a negative impact on the product and the functionality of that product. So everybody plays a winning role. And culture matters. We've talked about that a lot in the past. We got to have a culture where it's okay for somebody to stop, raise their hand, and say, hey, this doesn't make sense. I'm not doing it this way. Are we sure this is the right way? They're not going to just deviate from the instruction, but they do have the precedence has been set that it's okay to ask, excuse me, before proceeding. When in doubt, follow the OEM's recommendations or requirements, because, again, they're the ones that are going to be determining the proper usage of the product, the proper usage of their particular component of that product. The design authority is going to be making some determinations there as well, but we just need to make sure we're following all those requirements. My last slide, and then I'll let Mike jump in for a sec. Must understand the contract and the contract's requirements and the product safety. Again, using that definition of product safety, the state in which the product is able to perform to its designed or intended purpose without causing unacceptable risk of harm to persons or damage to property. If we think that the propeller, using that picture, if we think that the propeller is just a big fan, we're missing the point. We're missing the design intent, and we may be making some bad mistakes associated with controlling the product. A little light humor here, but it's important for us to understand what it does and why it does it, so that we can ensure that our product is being, or our processes are not having a deleterious or a harmful impact on the product and the end product for our customer. So that's all I had. Mr. McRandall, anything you want to add to the reviewer commentary before we go into the Q&A period?
No, not really. The biggest takeaway from this, I think, that I'd like to see people get is the fact that product safety ties in with all of this cleanliness, FOD, preservation type stuff. It's kind of a new thought process for business, but it shouldn't be. It's always been there. And the fact that the culture is so important. And again, I don't know if you guys can hear me. I've been having some mic issues. But culture in any businesses, in any climate, is so important. And you set that culture. People need to understand that just because they make a particular widget or they make one part of a product, that it does go into something else, and it doesn't hurt to know where that goes and what it's going to impact.
Absolutely, absolutely. For those that want to know more about that culture piece, we've got some great webinars that are available on our website, and I'll show you that link in just a minute. Before I get to that, I want to have everybody take this time to type in any questions that you may have associated with the webinar, the topics that we've covered, or really anything else that you may want answered. If it's too out there, we'll address it offline, but anything that's related to the topic or anything that's related to the industry, we can definitely help go through those now. So go ahead and type those into the chat function. I'm going to finish up the last couple of slides here, and then we'll wrap up. So the webinars are available from our NSF website, and Katie will send you a link to this webinar. You can also, or there should be a link to the other webinars or the landing page associated with those. If you forget where that's at, from the nsf.org/info/ISO-updates page, you'll see the AS9100 2016, and then down here you'll see the webinars. Now, for those of you that won't remember that website, if you go to the nsf.org website, under services, you'll see aerospace. You can navigate to the AS9100 and 9100 2016 panel, and it will have the webinar series listed there. If you click on the link, the hyperlink that's in this section, you'll be able to get to all of the webinars. We've got one on product safety. We've got one on human factors. We've got one on a number of topics that are really related to this and that we've glanced over here, but they all really tie together. So if you're looking for more information on that or any topic, it's a great source for you. Another great source of information is from the IAQG website. Two items that I want to highlight in particular. The first one is the Supply Chain Management Handbook. A lot of the information that we use to come up with these webinars comes out of that Supply Chain Management Handbook. It's a free resource associated with the aerospace supply chain, but it's available to anybody. So if you have questions on a particular subject, feel free to jump in there. They have white papers on anything and everything you can think of, from FOD to counterfeit to how to do contract review. Tons of great resources in there. I use it pretty consistently. Another great source of information is from the standards questions. You can get to this, as I've said in the past, 3 different ways. You can click on this link, or this link under Deployment Support Materials. The Deployment Support Materials and the standard questions will take you to a matrix of all of the standards, and from there you can select 9100. If you click this 9100 box, it'll take you directly to the 9100 section. And under that, there's a clarifications document, there's an FAQ document, there's an auditor guidance material document. All of those are excellent resources associated with the standards expectations, the industry's expectations, and really anything that has been clarified from the industry. The last slide before we start doing the questions and answers is regarding June's webinar. Our next webinar is going to be on the subject of competence under Section 7.2. And what does it mean, and how does it all tie together with the human resources component? As we know, humans play a huge role, or significant role, in building our system and keeping it running, and we need to assure that those people are competent to do the work. So what does a competence program look like? What's required? And what are some common pitfalls associated? That's what we're going to cover. It says the registration info is going to come soon. Katie and I landed on a date today, and I believe we picked June 21st. Katie, correct me if I'm wrong, June 21st, 1 p.m. Eastern. Is that correct?
That is correct.
Perfect. So with that said, this is the time for questions and answers. I'm going to leave this slide up so you have Mike's contact information and my contact information. If you don't have any questions, or if you want to jump off now, I'll say thank you very much for attending. Thanks for your continued support. We appreciate everything you're doing to help us, help you, and have a great day. For those that have questions, I'll go through those now. And I'm not seeing any questions pop up. Oh, it looks like there's a couple up here. Well,
Again, everybody, I know that Don mentioned that I will be sending out an email to everyone that is registered for the event. You can expect to see that within the next couple days, and it will have to download a copy of the slides as well as a link to go to the full audio and video recording of it. So you can expect to see that within the next week. And as I don't see any questions coming in, if you do want to contact Mike or Don directly using the contact information that is on the screen, you can go ahead and do that. So we really want to thank you guys for your continued support. There'll be a survey also sent out, and we would love feedback on what topics you guys would like to do future webinars. But if anybody doesn't have any questions, we'll go ahead and end the session.
Thanks, everybody. Appreciate you attending.
Have a great day, everyone.